Hey folks, this is an example video for section 4.4. So if you would go down to example number 6, the very first part of the directions says that we should graph this by hand. You'll notice I've been given a polynomial, and they were really nice to us on this one. They not only gave us the polynomial, they also gave us the factored version. So this one's pretty easy as far as graphing is concerned. But go ahead and look at the original polynomial, the standard form, and you'll see that the degree is 3. So we know that if the degree is 3, that my end behavior, 1 up, 1 down, leading coefficient is positive, so we're going uphill. Secondly, we can find easily the y-intercept. Look at the standard form again, plug in 0 for all your x's, and you'll see that your y-intercept occurs at negative 30. We can write that as a coordinate 0, negative 30. And then the third thing that I'd like to look at is that all of the zeros, look at the factored form, all of the zeros are breakers because there's only one of each. So then graphing is really simplistic. I've already marked my x-axis with the 3 zeros. Let's follow our end behavior. So we're going to start at the bottom. We're going to come up and break through the negative 5. Let's break through the negative 2. And then come back to break through the positive 3. Wherever you crossed over the y-axis, just call it negative 30, and that way you don't have to count 30 blocks, which gets a little tedious. Now let's go to the second part of the directions, which says to solve. And then the solving, this is the part A, B, and C that we're going to look at. So the first part here, part A, says that P of X is equal to 0. We've already done things like this, and so this is nothing more than taking our standard or our factored form and setting it equal to 0. Literally, where are my solutions? Where are my zeros? Where are my x-intercepts? Another way we could say this is I want all the places of my graph that are on the x-axis. So this is something that we've been doing now for several sections in this chapter. On the x-axis, we know occurs at 3 spots, at x equals 3, x equals negative 2, or x equals negative 5. You could also rewrite these as coordinates, so you could have written them as the coordinate 3, 0, the coordinate negative 2, 0, or the coordinate negative 5, 0, and that would also have been correct. Now let's go to the second part of this that says that my polynomial is less than or equal to 0. This time it's not just on the x-axis, although the equal part of this does tell me I want the on the x-axis, but it's also less than 0. And less than, we know these are negative numbers, so we want below the x-axis, below the x-axis. So it's not just the ons, it's also the belows. So let's come over to our graph and you'll see that here's a piece that's below. We already know that that piece is on. Here's a piece that's on. Here's a piece that's below. And here's a piece that's on. So somehow I want to write down all of the places on my graph that are either below the x-axis or on the x-axis. I can do this through intervals. And so my first interval is going to be from negative infinity to negative 5. Notice that I used a square bracket because I also want the pieces that are on the x-axis. And then I've done an interval from negative 2 to positive 3, again, including those places that are on the x-axis. All right, so now let's move to part C, which says that I want all of the pieces that are greater than 0. Now let me erase my highlighted pieces here. I want all of the pieces that are greater than 0, not on the x-axis. I only want the parts that are above the x-axis. So I have a piece here that's above, and I have a piece here that's above. So somehow I need to write down the above pieces. Use intervals again. My first interval, notice, is going to be from negative 5 to negative 2. This time I will not be using the square brackets because I don't want the on pieces, I only want the above pieces. So from negative 5 to negative 2. And then the second piece that's above is going to be from 3 out to infinity. Again, using round parentheses because I don't want any of the ons. I only want the aboves.